Okay, suppose x of n is sequence 1, 2, 6, 7, 9.
You have to count the number of points in there. 5.
Yeah.
L equals 5. L is the length of this one.
Okay, and then h of n is sequence 1, 5, 6, 3, 8, 9.
Now you have to count this length as M.
Okay, 6.
6. Read.
Okay, how many padding zeros are needed to convert their circular convolution to their linear convolution?
Okay, there are two things. One is circular convolution versus the other is linear convolution.
Okay.
And well, circular convolution has got by default everything periodic. Linear convolution is by default everything aperiodic. Circular convolution by default we will do discrete Fourier transform. For this you will do Z transform. Actually, linear convolution calls for a Z transform, and circular convolution calls for a discrete Fourier transform. Just remember that.
Okay.
Then here you will do circular shifting. Here you will do linear shifting.
Okay.
All that. But now for linear convolution, or rather we should write other way around, circular convolution to be equal to linear convolution. Okay. The condition is L plus M minus 1 should be the length of the sequences. Now in this case, we will have L plus M minus 1 equals, what is this value going to be? 5 plus 6 minus 1. That is 10.
Oh, 0. Yeah, 0.
That's 10, right?
Oh, yeah. Oh, yeah.
Write x of n at 1, 2, 6, 7, 9, 5, 1, 2, 3, 4, 5 zeros.
That's it?
5 zeros. And h of n equals, what was that? 1, 5, 6,
3, 8, 9.
8, 9. We write 1, 2, 3, 4 zeros. This is called as zero padding.
Okay.
Now, if we do x of n, circular convolution, so convolution with the circle, h of n, it will be same as x of n, linear convolution with h of n. That's it.
What's the difference?
That's, oh, big difference. The answers are completely different. That's why I told you the difference over here. That when you're doing circular convolution, the signals are assumed to be periodic.
Okay.
And then you will have to do different ways of solving. The formula is going to be a bit different.
Okay.
So there is a difference. But then if you want that difference to go away, okay, you will simply do this padding. And when you do this padding and make that length equals L, this is the magic factor. When that L plus M minus 1 equal minus 1 is the length, you will definitely get the circular convolution equal to linear convolution. That's it. I'll save this.
So, okay, so at this point, we got the thing for both of these, the x of n and h of n. So what's the difference on the x of n and the h of n? Is the x of n represents what the...
Well, you don't have to worry about that right now in this question at least. In this question, you don't have to worry about that. Because the question is asking you how many zeros do you need. So you need 5 zeros for x of n, you need 4 zeros for h of n. And then now even if you do circular convolution, you will end up with a linear convolution. That's all they're asking right now.
Okay. So the answer is the five for the x of n and 4 for the h of n for the zero padding.
Yes.
That's it.
Yes, I'm clear. Clear this?
Yeah.
Okay. Now, the next question we should look at is question number 8,
Okay.
because that will give you a better perspective.
Okay.
Well, when you have a system, it is written as h of n. Do you know that?
Yeah.
The input is x of n and the output is y of n. So now this is an input. The x of n is the input and y of n is the output. Okay. And we know how this relation is, right? The relation is y of n equals x of n convolution h of n. So when you
Yeah.
perform convolution of input and system, when these two are convoluted, you get the output y of n. Okay. So now question 8 says how convolution is performed in DSP system using FFT. Okay. So
Convolution
now,
DSP.
listen. Okay. Let's say you have x of n and the length is L. You have h of n and you have length is m. Okay.
All right.
Then this both will go through zero padding. It will make sense in a minute. Just pay attention. This will also do zero padding. And the zero padding will do is of the factor L plus m minus 1. So say both of them are 4 length. Okay. So we'll do 4 plus 4 minus 1. That is 8 minus 1, 7. So we'll make the length 7. Okay. Now this
Okay.
x of n will be L plus m minus 1 and h of n will be L plus m minus 1 as well. Now you're free to do FFT, which is nothing but same as DFT, but the FFT is faster and better. Okay, you there?
Okay. Yeah.
So once you do FFT, you're going to get x of k, and the FFT of h of n is going to be h of k. Then you just multiply these two. When you multiply, you're going to get them as x of k times h of k. Then you will do inverse fast Fourier transform. Then you'll get x of n convolution h of n. I hope you know this is the property of transforms. But now the point that you have to understand is when you're doing DFTs and FFTs, okay, it corresponds to a circular convolution, as I told you in the previous discussion, right?
Mm-hmm.
That DFT and FFT will correspond to a circular convolution. But in our case, this will be exactly equal to x of n linear convolution with h of n.
Okay.
Because we did this.
Okay.
If we would have skipped this step, then we wouldn't have got this. And the answer would have been just circular convolution.
Okay.
Right? So we want to find linear convolution. So we have to ensure that we do the zero padding. So they have both similar questions. Can you now read the question and see if it makes sense?
Okay. The question is explain how convolution is performed in a DSP system using FFT.
Yes. And why we make use of FFT? FFT is the best. It's a best transform. Okay.
Okay.
Because one, it is fast, and two, it is an algorithm. Algorithm in a sense, in algorithm or flow graph. Therefore, it is machine friendly. Computer is very easily can figure out, fast Fourier transform is very easy. Like the time we've done the project also, we have used fast Fourier transform. That's a very easy to achieve transform.
Okay.
Got it? That's it. That's the answer.
So okay, the diagram itself, we go through x of n, h of n, and we do our zero padding.
Yep.
We get our L minus or L plus m minus 1, which is going to give us our sequence length.
Yes.
And so once we get our sequence lengths, we know our padding.
Yeah.
So once we know our padding, we do our padding. From there going forward, is that called FFT when we do our padding, or what does the padding have to do with the FFT part?
Oh, well, padding has nothing to do with the FFT part, but just that when you do padding before you do FFT, your circular and linear will be same.
Okay.
If you don't do this, then what happens? If you skip this step and directly do FFT of this, then only thing is this will not be equal to this.
Okay.
So you're going to end up with a circular convolution and not the linear convolution.
Okay, so in your words, like in actual words, how would you describe like how the convolution is performed in a DSP using FFT in your words? Like I know we did a diagram, but in actual words, how would you explain that?
Well, this diagram is self-explanatory, right? You take your x of n and h of n, do the zero padding. After you do the zero padding, you get x of n and h of n padded up. So for example, okay, let me give you an example to make you understand. So if you have x of n is say, x of n is like a 4-length sequence, and h of n is also 4-length sequence. Okay.
Yeah.
There are 4 things in there.
Yeah.
And now if you take a FFT, you're going to get x of k.
Okay.
If you take a FFT, you're going to get h of k. The FFT of h is going to be h of k.
We're getting the FFT of the sequence, a new sequence that's been padded, right?
Without padding, if I take that.
Without padding.
So then I'll get x of k and h of k. Then I'll multiply x of k and h of k. I'll get this as well. Then I take an inverse fast Fourier transform. I'll get the circular convolution. But hey, that's the circular convolution and not the linear convolution.
Yeah.
You get my point?
Yeah.
So, but then you know what? We right now need it to be a linear convolution, right? Like this one.
Okay.
So if you want a linear convolution, you have to ensure that you do the zero padding. Now what would you do? You will just make that x of n of length 7. Because this is 4 and this is 4. So 4 plus 4 minus 1, that's L plus M minus 1. 4 plus 4 minus 1, that's 7, right?
Yeah.
So you will make the length of x of n and h of n, both of them, 7.
Okay.
Right? You did the length 7. Now you find DFT and FFT. Now once you do DFT and FFT of the 7th length sequence, you still get x of k and h of k. Then you will do then you will multiply them. Then you will take an inverse transform. You get x of n convolution with h of n. The answer is supposed to be circular convolution. Supposed to be. But then that is same as the linear convolution.
Okay.
That's it. And that's the effect of the padding part that we did.
Okay, so when they say to explain how convolution is performed, this process is the convolution being performed here.
This process is the exact answer to the question.
Okay.
Diagram is even better.
Okay.
So I think we figured out all the questions from 6 to 10. Except
we got 6, 7.
The 10th is going to be crazy for solving. It's going to be tough.
So we got 5 also. So we need 1
let's
through
10.
4.
Let's do 10.
I'll do 10? Okay. Okay.
Now, this is going to be one. Find it 6-point DFT. I don't know. Why would you find 6-point DFT? You see, the x of n is 1, 2, 3, 4.
Yeah. Okay.
Last time we have solved this question at all already.
Yeah. Yeah.
But right now, this is n equals 4. The length is 4.
Okay.
But then what the question is asking is find 6 points DFT. Okay. So when you find 6-point DFT, you simply have to do the zero padding, and x of n will be 1, 2, 3, 4, 0, 0.
Okay.
And finding 6-point DFT is a crazy task.
Okay.
It is very smart to keep signals in powers of 2. Right? 2 to the 1, 2, 2 to the 2, 4, 2 to the 3, 8, even 2 to the 4, 16 is easy. But 6 is not.
Okay.
I'm sure, I mean, I can find out, but then it's going to take forever. So do you want to do this?
Well, you said you want to do 10, right?
I can do, sorry?
You said you wanted to do 10, right? It don't matter. We can do a different one. I don't.
You know, all I'm trying to say is there is really no way to solve N6 DFT.
There's no way to do that.
Let's just quickly give it a try. Solution.
If not, maybe that could be one that we can touch on tomorrow. But and maybe we can go over like n equal 8. Maybe maybe that's variation that can be.
I already did n equal to 4 by fluke.
What's the difference? What's the difference? Like if so, the 6 points is the amount of padding we're gonna have to do. That's the sequence length.
Yes.
The 6 points.
Yes.
Okay, so if we did n equal 8, then it would be 8. We had to pad up to 8
Yes.
zeros.
Yes.
Or like zeros up to, yeah. Okay, so in that case, the process would be the same as what we did previously for the 6 point problem or the 4 point problem.
Do you remember this one? You see my screen, right? Do you remember this one?
Yeah.
This is what the DFT is like. This is the fast Fourier transform or FFT. Okay.
And this is 4 points, right?
This is 4 points. So 1, 2, 3, 4 we've already solved.
Okay, so if for the 8 point case, it would just be the same, but we're just going to do 8 instead of 4. Everything's the same.
This will just double up.
Okay, so nothing changes as you go higher in the amount. You just add more layers, I guess.
A few things do change, but not way too much.
Okay.
Yeah, the few things do change. Right? The graph is going to look very different. But then I don't see any question of 8 point as such. The question is asked for 6 points.
Yeah. I'm just saying in case if they come out with a different amount instead of 6 point, let's say they do 8 point or something. I want to know how to be able to manipulate the the graph here, I guess. So on the x's, how does that work as you go up?
Let's do 6. It's just going to be a lot of solving.
Okay.
I think we can still get the answer. Well, first you will need something called as DFT formula, and the DFT formula is x of k is equal to sum of n equals 0 to n minus 1 x of n wn raised to nk, and this wn raised to nk is called as twiddle factor. Heard of the term? Where wn raised to 1 is nothing but e to the negative j 2 pi by n. That's wn to the 1. Well, let me explain what I mean. The n is the length, and n is 6, so n minus 1 is going to be 5, right? So let's put the values x of k. Let's put n equal to 0 first. So you get this as x of 0 and wn to the 0. Then x of 1, wn to the 1k, n is 1. You get that?
Yeah.
X is 2, wn raised to 2k. And on the last one will be x5, wn to the 5k.
Okay.
Then do you know x0 is just 1?
Yeah.
X2 is 2. X1 is 2.
Okay.
And last two are 0 anyways.
Okay.
So what do you get x of k as? Let's write down. Look, wn raised to 0 is also 1. Anything power 0 is 1. So this first term is 1.
Okay.
Then you have 2 wn raised to k. Then you have 3 wn raised to 3k. Then you have 4 wn raised to 4k plus 0 plus 0. The last two are 0. Do you get this?
Yeah.
Okay. Now once you get that x of k, we know that k is going to go from 0 to 5 as well. Because n was going from 0 to 5. And 0, 1, 2, 3, 4, 5 for x of n.
Wait. When we look at the we have x2 wn 2k, right? The last term before for dashes there.
Which one?
Yeah, right there. The x2. No. Look on the last term before your dashes. You have x2
Oh,
wn
yeah.
raised to 2k.
Yes.
Okay, so
x2 is 3.
yeah, okay.
That is the value of x of n 3 when n is 2.
Okay, so how do we get 3k down there if we have 2k up there?
Because 3 wn to the 2k. Yeah, sorry. Oh, sorry. My bad. It's 2k.
Okay.
Yeah, perfect. You saved
Got
me
you.
a great deal of time. Anyways, good. So this is how it's going to be. Okay. Now, do you understand? K will go from 0 to 5 because n is going from 0 to 5.
Yeah.
All right. So let's put k equals 0. Now, that's the easy part. K equals 0 is going to give you x of k equals 1 plus 2 plus 3 plus 4 equals 10. Because everything will become 0, right?
When k equals 0, yeah.
And wn to the 0 is going to be 1.
Okay.
So 1
Gotcha.
is also 1.
Gotcha.
1 plus 2 plus 3 plus 4. And the answer
Okay.
is 10.
Okay.
Let's put k equals 1. X of k will become x of 1. This was x of 0.
Yeah.
What is x of 1 going to be? 1
X of 1.
plus 2 wn to the 1.
Mm-hmm.
This is, oh, I'm sorry. I should have cleared that. 1 minute. This was k. Okay. Now let's put k equals 1. So you'll get x of, this was x of 0. This is x of 1. X of 1 is going to be 1 plus 2 wn to the 1. Now it's k is 1, right? I put,
Yeah.
and then
Okay.
3 wn to the 2 and 4 wn to the 3. Now all we have to do is find what is wn to the 1. And this is what I was saying, that it's going to be a task. Okay, so I'll tell you what is wn to the 1 over here. Wn to the 1 is e to the negative j 2 pi by n, and n is 6.
Okay.
So you get this as e to the negative j pi by 3.
Okay.
Cos pi by 3 minus j sine pi by 3. Do you remember e to the j theta?
Yeah. That Euler's theorem.
J sine theta, the Euler's theorem. When you have plus, you have plus. When you have negative, you have negative here.
Okay.
Okay, so now we have to now we have to find out what is cos pi by 3. Cos 60. How much is it? Half?
I don't know. I'd have to look at the unit
Half.
circle.
And yeah, j, this is square root 3 by 2. This is the value of wn to the 1.
Okay.
So you're going to get 1 plus 2 times half minus j square root of 3 by 2 plus 3. Now wn to the 2. What will be wn to the 2? That is wn to the 1 squared,
Okay.
which is half minus j square root 3 by 2 the whole square.
Okay.
Let's square this. 1/4, the square of 1/2,
Yeah.
minus 2 times half j square root of 3 by 2. I'm just expanding this a minus b the whole square.
Yeah.
And then the last one is going to be the square of this. Minus, the j square will become minus 3 by 4. Is that correct? I'm just doing a minus b the whole square. A square minus 2ab plus b square.
Okay.
Do you get that?
Yeah. Not sure exactly where the 3/4 comes from.
Because it's a square of this term. Good question. What is square of square root of 3? 3.
Yeah. Yeah.
Square of 4, 2 is 4.
Okay.
And negative because it is j square. And j square is negative.
J square is negative.
Yeah.
So j square is -1?
Yes.
Okay. Okay. All right.
So that's how I got. Okay. Now
Okay.
let's club the real part together. So this is going to be, this is a real term and this is a real term. So tell me, 1/4 minus 3/4 minus 2 by 4. This 2 will cancel out. Am I doing it correct?
I believe.
Yeah, let's hope so. I mean, you can just like verify calculations later on once again. So this is -1/2, and then this is minus j square of 3 by 2. I'll just put that here. That's -1/2 minus j square root of 3 by 2. Then this will be 4 times. Now you have to find out wn to the 3. Okay, so this was wn to the 1. Then we solved for wn to the 2. Now wn to the 3 is going to be here. Wn to the 3 is going to be wn to the 1 times wn to the 2. And we have wn to the 1 as half minus j square root of 3 by 2. And wn to the 2 is this. This is -1/2 minus j square root of 3 by 2. So I can take minus out from here. So I'll get, I take this minus out. Okay, let me highlight that a little bit. What if I take the minus sign out? This will become plus.
Yeah.
And then there is a minus sign outside.
Okay.
And then you have a minus jb, a plus jb. Now you have to remember the formula. A plus ib times a minus ib is going to be a square plus b square. And our a is half. And b is square root of 3 by 2. So a square is going to be 1/4 plus square of this is going to be 3 by 4. So this is 4 over 4, negative 4 over 4. That's just -1.
Okay.
So we have wn to the 3. The answer of wn to the 3 is -1. Wn to the 3 is -1. And not that tough, all right? So we are getting the answers. So this is going to be -1. We have to simplify this more. X of 1 is going to be, now we have to deal with the real and imaginary part separately. So you have 1 plus, this term is going to be 1. Yeah. Then this term is going to be -3 by 2. This is going to be -4. All the real part. Plus with the j. What all imaginary part? 1, 1, -3 by 2, -4. The real part. The imaginary part is going to be negative square root of 3 by 2. Then this would be -3 root 3 by 2. Are you getting what I'm saying?
Yeah.
And that's it, right? There are two imaginary parts over here.
Okay.
So let's club them. And then x of 1 is going to be 1 plus 1 is 2. 2 minus 4 is -2. So you have -2 minus 3 over 2, the real part. And for imaginary part, that's j Denominator is 2 common, then it's negative square root of 3 minus 3 root 3. All right, I told you it's going to be crazy. So x of 1 is going to be, we'll take the minus out, and then over here it's going to be 2 plus, if I take the minus out, it's going to be 2 plus 2 by 3 by 2, that's 4 plus 3, 7 by 2, negative 7 by 2, this thing here, plus j, what if I take,
Wait, where's the 7 from? The 7?
I just cross multiply, right? 2 to the 4.
Hold on, because my screen is kind of not showing good right there. Hold on, give me 1 second. Okay, so you okay.
2 plus 3 by 2. That's how it is.
Oh, okay, I got you. Okay.
That's 7 by 2. Then minus. I took the minus out here.
Okay.
J. I take square root of 3 out. So you get negative 1, negative 3. Sorry. Plus 1, plus 3. Minus is already out. By 2.
Yeah. Okay.
I have got minus 7 by 2. Minus j. This is 3 plus 1 is 4. 4 by 2 is 2. 2 square root of 3. That's the answer of x of 1.
Okay.
Now, after we get x of 1, next we have to find out x of 2. Then k equals 2, right? Tell me, we'll put k equal to 2 in this expression here. Tell me. X of 2 is going to be 1 plus 2. This will become wn to the 2, right?
Real quick, because I'm not quite seeing some, I guess, bigger picture. Why are we solving for x1? We were looking for x1, and we got all the values, 2 times w1 plus 3 times w2 plus 4 times w3.
Yes.
We found all those values.
Yeah.
So what are we? I'm not seeing exactly what we're solving for if we found those values.
Okay, I'll tell you what it is. Let me clear some space. We are just trying to get x of k. That's the question is asking for. Look, we are trying to find out the value x of k. The first x of 0, the first value is 10. This we got at k equals 0. You see?
Yeah.
Now we're putting k equals 1 into this expression here.
Yeah.
When you put k equals 1 in this, you get x of 1. And the answer is over here. That is the first one at k equal to 1. This is the value. So let me write that. That's going to be minus 7 over 2 minus j 2 square root of 3. That's for k equals to 1. Now we want to find the value for k equal to 2.
Okay.
Then we'll do for k equal to 3. Then we'll do for k equal to 4. And then we'll do for k equal to 5.
Okay.
And that's how your x of k is going to be.
Okay.
Okay. But now there is a beautiful symmetry in this answer.
Okay.
So, n plus 1 by 2 is the point of symmetry.
Okay.
You remember the last time when I wrote x of k, the first value was 10, then 2 minus 2j, 2 plus 2j, then 2, then 2 minus 2j.
Something like that.
Yeah. So basically you're going to get a symmetric answer. So we just have to find out of 6, we have to, I think, only find out 3.
Okay.
And the rest of them will be repeating.
Okay.
Okay. Okay. So I'm teaching you now circular convolution. Okay. So write down the x of n with the 1, the first term as it is. You there?
Yeah.
And everything else is inverted. So it is 0, 1, 1.
Everything else is inverted. Shouldn't that be 0, 0, 1?
So this, instead of writing 1, 1, 0, you write 0, 1, 1. You write from here 0, the 1, and the 1.
Oh, okay. You're starting from the opposite side. You're not, okay.
I'm inverting them.
Okay, I got you.
Next, you write down this as, okay, you write down xn as it is. Sorry. Xn, you write down this as it is 1, 1, 1, 0. And this on, you do that. Okay, you write down hn. This is xn, these values. And then you write down
Okay.
hn, the first one as it is, and these are inverted.
Okay.
Okay, so it's
0,
going to
2.
be 0, 0, 2.
Okay.
And then find out, just multiply and add. 1 into 1 is 1. 0 into 1 is 0. 0 into 1 is 0. And 2 into 0 is 0. So that's just 1.
Okay.
Then you write down h of, okay, forget all this. Then you just shift it, okay? And it's called a circular shift. So 1 goes here, 2 goes, 0 goes here, 0 goes here, and 2 makes a circle. And that's what is called as a circular shift. So 1 goes here, 0 goes here, this 0 goes here, and this 2 comes here. Do you see a circular shifting happening?
Yeah.
And then multiply 2 with 1, this and this. That's 2. 1 with 1, that's 1. 0 with 0 and 0 with 0. So you get 0 plus 0. That's 3.
Okay.
Keep doing that. So 2 shifts again here, 1 shifts here, 0 shifts here, and then this 0 goes here.
Okay.
Then multiply with x of n again. So it's 1 and 0. 0. Then 2 and 1. 2. 1 and 1. 1. 0 and 0. 0. That's 3 again.
Okay.
Keep shifting. So write down 2 here, 1 here, this 0 here, and this 0 here. Basically, this 0 shifted, this 2 shifted, this 1 shifted, and this 0 jumped back.
Yeah.
Again multiply. 0 times 1, 0. 0 times 1, 0, 2, 0. The answer is 2. Yes?
Yeah.
And you should stop here. Because if you don't, you will get 0 here, this 0 here, this 2 here, and this 1 here.
That'll be the same thing you started with.
This is the same thing that you started off with.
Okay.
So this is your answer. So your yn is going to be 1, 3, 3, 2.
Okay.
You have to note, we perform circular convolution, but the answer is linear convolution
Okay.
because of the padding.
Okay.
That's it.
Okay.
So we got the answer. What is the question really like?
Perform their circular convolution with padded 0 such that it would be equivalent to their linear convolution. So yeah, that's it. That's for A. Now we have B.
Yeah.
So B says find xk, hk using FFT and yk equals xk convoluted with hk.
That's a mistake. It's a multiplication. It's not a convolution.
Oh, okay, multiplication. Select the correct number of points for FFT.
4 points always.
What's that?
4 points.
4 points. How do we show that?
I'll show you how that's done.
Okay.
Save. I'm clear. No, I'll have to erase few things now. Do you remember the answer? Okay, 1332. Huh?
Yeah.
We're going to get this answer later on.
Okay.
So now this circular conversion, let that go. Okay, we've done the padded zeros, right? Already, the padding has been done, and everything is a 4 point. 4 point is beautiful. It's easy to deal with, so it's going to be very easy to get it. Now we are asked to find out x of k and h of k using f of t, right?
Yeah.
You know how to do that? You draw 4 lines, 1, 2, 2, 3, and 4. Then small cross. This is called as the butterflies. Butterfly diagram is what is called as 1 and 3 connect, draw parallel, connect 1 and 3, draw parallel. This is -1. Hey, do you remember this? This is -1, -1, and -1, and minus j. Then this will be the 0 and 2, x0, x2, x0, x2, and this will be x1 and x3. Okay.
How do we know that we're doing 4 lines in this case? Is it because our padding was 4?
Because the length of the sequence is 4.
Okay.
If the length is 10, then you will have 10 horizontal lines.
Okay.
Yeah. And then there is a reason why the graph is like this. There is a derivation to that, which we are skipping.
Yeah.
Okay.
Right.
So, well, now once you have the graph ready, it's time to write down the values and solve this, right? So we have the first value is 1. Okay. So let's take that. Tell me. X0, right? This is the 0th value. That's the arrow over here. This is 1. Now what is x2? 0, 1, 2. x2 is 1. What is x3? What is x1? 1. Am I making sense?
Yeah.
And then this is 0. At least you're following the method, right? So it's just 1 flows in, 1 flows in, 1 plus 1 becomes 2. This one goes down as well over here. 1 minus 1 becomes 0. Do you get that?
Yeah.
1 and 0 is going to be 1 over here at this point.
Yeah.
And 1 and 0 gets multiplied with -1. The arrow basically means you multiply.
Okay.
So 0 and 1 and 0 is going to be just 1.
Wait.
1, yeah.
1. Oh, yeah. Oh, yeah. Yeah, you're right. Okay.
1 times minus j is going to be minus j.
Okay.
This is at this point.
Yeah.
Then 2 comes here and 1 comes here. 2 and 1 is going to be 3. The 0 comes here.
Wait. Hold on real quick. The 3, we're saying that we're getting, okay, 2 from there and 1 from there. Okay. Got you.
That's 3. Now you got 0 coming from here. And
Okay.
negative j coming from here.
Okay.
0 and negative j is going to be negative j.
Okay.
And then 2 and 1 comes here with multiplies with -1. So that's -1.
Okay.
2 and -1 is going to be 1.
Okay.
And then 0 and negative j becomes positive j.
Okay.
And that's just positive j.
Yeah.
And that's your answer. 3, negative j, 1, positive j.
Okay.
That's x of k.
Okay.
Now similarly, you'll find h of k. How will you do that? Same graph. Shall we use same graph?
Okay.
I'm just like a little too lazy to draw the graph again.
That's fine.
So let me just use the power of colors. So you tell me what are the numbers here? 1, 2, 0, 0, right? So it's going to be 1, 2, 0, and 0.
Okay. All right.
Then this is 1 and 0 is just 1.
Yeah.
1 and negative 0 is just 1 again. 1 and negative 0, right? That's just 1.
Yeah. Yeah.
2 and 0 is 2.
Okay.
2 and negative 0, 2 minus 0 is 2. Then 2 times minus j is negative 2j. And then this is 1 and 2. This is 3. I got the first value 3.
Okay.
Then the next value is, well, this is 1. That comes here. And 2j. This is 1 plus 2j.
Okay.
Then 1 plus 2j. And the next is, well, this is 1 and this is negative 2. That's just negative 1. Then this is, what is this? So 1 and negative 2j. Oh, this is the correct answer. This is correct. Okay. Take a photo. We can't afford to go wrong with this, so we'll just verify whether they're correct.
Okay.
It's 3, negative j, 1 j, and 3. Did you take the photo?
Yeah, I got the picture.
3 into 3 is 9. Then negative j times 1 minus 2j is going to be minus j times 1. And this is positive 2j square. That's minus 2. Is that correct? Minus j into minus j times minus 2j. That's, what is that? Minus j times minus 2j is going to be positive 2j square, which is negative 2. That's correct. So, and this value is negative 2 over here. And then 1 times minus 1 is going to be minus 1. And j times this, help me, j minus 2. I hope
Minus
j square is minus 1, right?
j squared. Okay.
It's a complex number, right?
Yeah. Okay.
I square is going to be minus 1.
So is that on negative j with the second element, negative j times 1 minus 2j? So I see we got negative j, and then we say minus
2.
Why minus 2?
J square is minus 1.
Positive, a plus.
J square is minus 1. This minus and this minus becomes plus.
Yeah.
And then there is j square, right?
Yeah.
And j square gives it minus sign.
Oh, okay, I got you.
Got it? Okay. So that's minus j minus 2 over here. That's your yk.
Okay.
We found out yk. What next?
Okay, so the next one is C. That one says find yn as an IDFT of yk.
Okay.
And it says, is it the same as in A and Y?
It has to be same. Now, once you get yk, you have to find IDFT. Now, there's a formula for IDFT. IDFT formula. Okay. Do you know DFT formula?
Okay. Not off the top of my head.
DFT formula, of course. So for sure, the DFT formula, I just like write down for you. X of k is equals sum of n equals 0 to n minus 1. This is what we used for the last time that answer did not come right.
Okay.
X of n, wn raised to nk. This was that big formula that we've used and the answer did not match.
Okay.
So now we have to do IDFT.
Okay.
So IDFT, you can just like remember like this. Look, DFT is when you find from x of n when you get x of k. That's DFT.
Okay.
Now this IDFT from x of k, you didn't need to get x of n. That's just the other way around.
Okay.
So it's back from x of k to x of n.
Okay.
So from y of k, we want to get y of n. So y of n equals, now, so IDFT formula is going to be y of n equals sum. Now sum will be for k going from 0 to n minus 1. Then this will be y of k here. And this will be wn raised to negative nk. And then there is one more point to be noted, that there will be 1 by n outside.
Okay.
And we're going to use this formula to find out the final answer.
Okay.
Okay. So now it's like this. For y of n, you write this as 1 by 4. That's the n, the length. The length is 4, right?
Yeah.
Length is 4. These are 4 points. Okay. So k will go from 0 to n minus 1. That's 0 to 3. Okay.
Okay.
So y is 0. Wn to the 0. Right?
Okay.
Y1. Wn to the 1. Y2. One
Negative, right?
negative n actually.
Negative n. Yeah.
Because k is substituted as 1, right?
Yeah.
Tell me wn to the negative 2n.
Yeah.
I3 wn to the negative 3n.
Yeah.
It's just the anti of what we've done before. So we just like solving the other way around. Tell me. Yn equals 1/4.
Okay.
1. This whole thing is 1. Sorry. Y0 is not 1. Y0 is 9, right? This value.
Yeah.
This is 9. Then wn to the 0.
Yeah. Okay.
And then the next term y1 will be negative j negative 2.
Okay.
Wn raised to n.
Negative n.
Negative n. Yes.
Okay.
Minus. This is minus 1. This
Yeah.
one.
Yeah.
So the minus 1 wn to the negative 2n.
Yeah.
And then plus j minus 2 wn to the 3n. Let's put n equals 0. 1/4. This will become y0, right?
Okay.
So the y0 here is going to be 1/4. 9 minus j minus 2. This is just y to the wn to the 0. And wn to the 0 is just 1. Is it not?
Wn to the 0. Yeah.
Then this is just minus 1. This is wn to the 0 again 1.
Yeah.
Then plus j minus 2. And this wn to the 0 is also 1.
Okay.
What answer did you get? Negative j, positive j cancels out. 4, 9, minus 2 is minus 2 minus 1 minus 3 minus 5. 4, 9 minus 5 is 4. 4 divided by 4 is 1.
Okay.
Check, this has to be the same value as that of convolution. Do you remember what was the value for convolution?
the value that I took a picture of?
Before that, we found a convolution, right?
I think so.
You remember circular convolution 1331, I suppose.
Oh, the very first thing we did.
Yeah.
Yeah. Okay. Yeah.
Is it 1331?
I believe. Hold on. Let me see. Maybe I did take a picture of that one.
Take the picture. Okay. So let's just solve one more, and then that's about it. I mean, it has to match. One is for sure matching. David, let's do one more.
Okay.
1/4 again, which is this number here. Then this is 9. Help. 9. Participate in
Okay.
this. That's going to be negative j, negative 2, this value. This will become wn to the -1 because now n is 1.
Yeah. Yeah.
Tell me next one. Minus wn to the -2.
Yeah. That's 2.
Plus j minus 2, wn to the -3. Okay.
Yeah.
Okay. So now we have to figure out these values now. What is going to be wn to the -1? It is wn to the 1 to the -1. wn to the 1 has a standard formula, e to the negative j 2 pi by n to the -1. That's the formula of wn to the 1.
Okay.
N is 4. So you get this as e to the negative j. That becomes positive, right? There's a minus outside.
Okay.
Positive j pi by 2, which is cosine pi by 2. You can just plug this in a calculator and find out this answer. If you have a scientific calculator, you can find out this answer. But anyway, this is cos pi by 2 plus j sine pi by 2. Sine pi by 2 is 1. Cos pi by 2 is, so you get this as j.
Okay.
Raised to 0. This should be minus j actually. I made some mistake then. E raised to wn raised to 1. Wn raised to 1 is e to the j 2 pi by n. Oh, there's no minus here. This is positive here. So then this becomes negative, and then this is negative, and the answer is minus j. Okay, so you get this answer as minus j.
Okay.
Now wn to the 2 is just wn to the 1, negative 2, right? Wn to the negative 1 square, right? Wn to the negative 1 is j. So it's j square, and j square is minus 1. That's wn to the negative 2, that's minus 1. And wn to the 3 is wn to the negative 2 times wn to the negative 1. And wn to the negative 2 is negative 1, and that's negative j. That's just a positive j, this value. Positive j.
So for wn to the 2, shouldn't it be negative j squared?
Wn to the negative 2, this is.
The negative 2
Is wn to the negative 1 square.
Yeah, so wn to the negative 1, isn't that a negative j?
Yes. But it doesn't matter.
Shouldn't it be positive 1?
Nope. The square is going to just like take care of that.
So j times j would negative j times negative j, shouldn't that be a positive j?
Well, it's negative j square. Okay. So when I'm squaring it, it's just j square.
Okay.
So negative will become positive here.
Yeah.
And then the j square is negative 1.
Yeah, I see that normally. I guess the negative doesn't make a difference then.
Yep. Because inside square, a negative will really not make a difference. Do you know what is
Okay.
4 square? 16. What is a 4 square? 16. Okay.
That's why I would think that it would just be 1, but I guess not. Oh no. I see.
Yeah, yeah.
I was thinking it would just be
Right,
J.
right. Let me write down that. This is j square. And
Okay.
that's why it is -1. Is it good now?
Yeah. Okay.
So w into the -2 is just negative. W into the -2 is just -1. Okay. So now I'm going to get the value of y of 1. What is the y of 1 value? 1 by 4. Sorry, help me. 9. Multiply the j inside here. This minus and this minus will make it plus. This is plus.
Yeah.
Then this j square is -1. And then this is 2j. This one here.
Why is that J squared? I don't see a square.
Yeah, j square. Because this is j, right?
Oh, okay. Yeah, I see.
Okay. Then next one will be minus of minus is +1.
Yeah.
And then this plus j you multiply in here. So it's going to be -1 this term. You
Okay.
multiply with j in here.
Yeah.
That's -1. J square is -1. And minus 2j.
Yeah.
Okay. So what do you get? The 2j will cancel out. The -1 and the +1 is cancel out. And 9 minus 1 is going to be 8.
Okay.
8 by 4 is 2.
Okay.
I hope that is the correct answer.